So far we have seen that if we have the vertices of the triangle, we can get the area using this determinant. The area of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 can be given as half of mod of this determinant. But what can we say about the points, about the vertices when the area becomes 0? Think about it. If this determinant is equal to 0, what can we say about these points? Well, if the area is 0, these points are collinear. And why can we say that? Well, because if we join these 2 points, we get one side. These 2 points, we get the other side. And these 2 points, we get the third side. Notice that the sum of these 2 sides is exactly equal to this third side, which means that our triangle has collapsed, which means that the points are collinear. Let's try this out. Let's find the area of the triangle with these 3 points as vertices. Pause the video, try this out. See if we get the determinant equal to 0. Okay, let's do this together. We have these 3 points, -2, 1, 3, 0, 1, 8, 2, 1 becomes our determinant. This is mod of -3. We're opening from the second row because we have a 0 here. -3 times -2 minus 2 plus 0 minus 1 times -4 plus 16. So this is -3 times -4 plus 0 minus 16 minus 4 is 12. So that's -12. Minus plus. So this means this is 12 minus 12. Mod of 12 minus 12, that's going to be 0, which means the area of the triangle formed by these 3 points is exactly 0. Now let's use this to prove a set of 3 different points as collinear. Show that the points A, B plus C, B, C plus A, and C, A plus B are collinear. Pause the video, try this out. Alright, so we have to prove that the determinant formed by these 3 points is exactly 0. So this is A, B plus C1, B, C plus A1, C, A plus B1. Let's expand this. We have A times C plus A minus A plus B, minus B plus C times B minus C, plus 1 times B times A plus B minus C times C plus A. This becomes A times C plus A minus B minus B plus C times B minus C plus 1 times AB plus B square minus C square minus AC. Can we cancel something? Yes, A gets cancelled. So we have A times C minus B minus B plus C times B minus C, that's B square minus C square, plus AB plus B square minus C square minus AC. This becomes AC minus AB minus B square plus C square plus AB plus B square minus C square minus AC. Now a lot of things get cancelled. We have 8 terms, minus B square plus B square, C square minus C square. So both the squares get cancelled. AC and minus AC, so this gets cancelled. Minus AB and plus AB, this also gets cancelled. So all 8 terms cancel each other out. What we have is 0. This means the determinant is 0, which means these points form a triangle with area 0, which means these points are actually collinear. Now what else can we do using this determinant formula? Well, if 3 points are collinear, we can use 2 points to form the equation of a line. Let's see how we can do that. We have these 3 points, all 3 of them are collinear. Let's forget about this point and only look at these 2. Can we form the equation of a line using these 2 points? Well, yes, using 2-point form, using slope point form, etc. But now we can also use determinant to find the equation of this line. And how can we do that? Well, the key is to take this third point as a random variable point on this line. If this third point is on this line, these 3 points are collinear, which means the area is 0. Now, if you assume this point to be x, y, this is going to be a determinant. Area will be half of, let's say this is our first point. So we have 3, 0, 1. This is our second point. So it's 8, 2, 1. And the third point is variable. So we take this as x, y, and 1. Now the points are collinear, which means the area is 0. So solving this determinant will give us a relationship between x and y, which is going to be the equation of the line. So let's solve this determinant. We have 3 times 2 minus y minus 0 plus 1 times 8y minus 2x. That mod of this equals to 0. So if mod of this is 0, this means this thing is 0. So this is 3 times 2 minus y minus 0 plus 1 times 8y minus 2x, that's 0. 3 times 2 is 6. 6 minus 3y minus 0 plus 8y minus 2x equals to 0. So we have 6, we have 8 minus 3, 5y, and we have minus 2x. So this is the equation. 5y equals to 2x minus 6. That's going to be the equation of this straight line. Let's check this as well. Let's see if this point satisfies the equation of this line. So if we put x as minus 2 and y as minus 2, let's see what we get. 5 times minus 2 equals to 2 times minus 2 minus 6. On the left hand side we have minus 10. On the right hand side we have minus 4 minus 6. So that's also minus 10. Minus 10 is minus 10, which means this point does satisfy the equation, which means we have the correct equation for this line. So in this way, we can find the equation of a line using determinants. Let's practice this. Find the equation of a line passing through the given points. So we have 3 sets. The first one is 1, 3 and 0, 0. Next one is 1, 2 and 3, 9. Next is 3, 1 and 9, 3. Use determinants to find the equation of these 3 lines. Pause the video, try this out. Okay, let's do this together. So we'll take the third point as x, y in all 3 of them. Here we have 1, 3, 1, 0, 0, 1, x, y, 1. Determinant of this is equal to 0. Let's solve this. We have, let's use the second row. We have 2 zeros here. So 0, 0 and 1, plus, minus, plus, minus, plus, minus. So this is minus 1 times y minus 3x. That's equal to 0. And because we're taking the mod, we can get rid of the minus sign. So we have y minus 3x equals to 0 or y is equal to 3x. So that's the equation for the line. Then we have this determinant 1, 2, 1, 3, 9, 1, x, y, 1. Let's expand this. We have 1 times 9 minus y minus 2 times 3 minus x plus 1 times 3y minus 9x. That's equal to 0. This is 9 minus y minus 6 plus 2x plus 3y minus 9x. That's equal to 0. So we have 9 minus 6, that's 3. We have 3y minus y, that's 2y. And we have minus 9x plus 2x, that's minus 7x. So we can rearrange this. 2y is equal to 7x minus 3. That's the equation for this line. Let's find the last equation. We have 3, 1, 1, 9, 3, 1, x, y, 1. Determinant of this, that's equal to 0. We can also expand using this third row, which has x and y. So let's do that. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So the third row has x times 1 minus 3 minus y times 3 minus 9 plus 1 times 9 minus 9. That's going to be the equation. That's equal to 0. So this is minus 2x. This is minus 6, minus, minus, plus. That's plus 6y. And then this is 0. This is minus 2x plus 6y equals to 0. Or 6y is equal to 2x. Or we can cancel 2 out. We have 3y equals to x. That's going to be the equation of this third line.